So it's still the same EQ. Try to use that for a while. Just a reminder that the journal test will be next week. So if you were absent or missed any days, be sure you get that from a friend. That includes the day that we left early last week. I had posted that journal in Google Classroom. And then hopefully you watched your video last night. You have another one to watch tonight. And then I think that's the last one for this week. Does anybody want to share with us what your perfect day would be? No homework.
No quizzes every week.
I need to increase my quizzes in here. Is that what you're saying?
No, because I don't even have time to process those. I think I'm just slow.
So nobody has a whole detailed day besides those little small things.
I get 12 hours.
12 hours, sleep warm.
Midnight or rest, and then 3 reps. Wake up and waking up and
Oh, okay. Oh, I do like a good breakfast. I don't usually eat breakfast, but like when I'm on vacation or something, I like to do breakfast.
And then I'm so like breakfast and brunch.
All right, if y'all will clear your desk, excuse me, but leave your timeline on there. Okay. So. I know I have a couple of people's timeline, I think. So we've been talking about the subatomic particles in the atom, and we're going to carry on with that, talking about isotopes. So isotopes are atoms with the same number of protons, which means the atomic number is the same, because that's what your atomic number does. It tells you how many protons there are. And that does not change, because we said atomic number doesn't change because it identifies the element. But they have a different number of neutrons. And because of that, the mass number will be different. If you remember back from middle school, mass number is equal to protons plus neutrons. So if the mass number is changing, it's changing because the neutrons have changed, not because the protons have changed. Usually isotopes are referred to by their name, or this is supposed to say or, not of, or symbol and their mass number. So for instance, you may see C12, that would be carbon 12. You may see it with the name. But if there's only one number with the name or the symbol, that's the mass number, because you don't have to have the atomic number, because you can always get that off of the periodic table. Every element on the chart has at least 2 isotopes, and some have many more than that. Even though the isotopes have different masses, they still have the same chemical properties. And we're going to look at some different ways to write the representations for our different elements. All right, so if you look kind of at a basic periodic table, you'll have the atomic mass on the top of the element, and that's represented by a Z. Then you'll have your symbol or the name of the element, or both. And a lot of times the symbol doesn't seem to match the name, like Na and sodium. You often do not have the mass number on the periodic table. So on the periodic table, I put PT for periodic table. You will see atomic mass. instead of the mass number. And those things are two different things. Atomic mass, which we'll learn about calculating that tomorrow, is not equal to the mass number. So like on your green periodic table, under the symbol, there's a number with a decimal usually toward the end. They don't have decimals anymore. That is the atomic mass. That is not the mass number. Sometimes you'll have to use the atomic mass to estimate the mass number, but what you actually see on the periodic table is going to be the atomic mass. Mass number is made up of protons plus neutrons. Sometimes you'll see this notation. You'll have a symbol or a name with two numbers in front of it. This is called nuclear notation because you're notating what's in the nucleus. So the bottom number is going to be the atomic number, and the top number is going to be your mass number. You may also see it as Na-23. That's a dash, not a negative sign. Or sodium -23. If there's only one number given, it's always the mass number. And the reason, once again, that is because I can always get the atomic number off the periodic table. Nuclide is just a vocabulary word. It's a general term for any isotope of any element. So you could say carbon has 3 nuclides. That means they have 3 different isotopes. Good. All right. The mass number is, oops, did I just do that one? Did I do atomic number? No. All right, atomic number represented by Z is the number of protons in the nucleus. Like I said, the atomic number identifies the element because atoms on the periodic table are neutral. They contain the same number of electrons as protons. Protons are positive. I have to have the same number of electrons to cancel that out, so it'll be neutral. Therefore, the atomic number is the number of electrons as well for neutral elements on the periodic table. When we start talking about ions, and we work with ions a lot throughout the year, ions are not neutral. So in that case, your protons would not be equal to your electrons. So for instance, if we were talking about sodium again, if I had Na and I could still have my 23 and my 11, but if it was an ion, it would have to have a charge. And sodium forms a +1 ion. So it would have to have that charge out in front of it. That tells me it's an ion. If it has a plus charge, has it gained an electron or has it lost an electron? Lost, exactly. Because remember, electrons are negative. So it would go from neutral to +1. It had to lose something negative. So it's lost an electron. My mass number, on the other hand, like I said before, is the total number of protons and neutrons in an atom's nucleus. If you don't have the mass number, if you don't have the mass number, use the atomic mass on the periodic table and round to the closest whole number. So that did not need a parentheses, just a period. So when you start working on your different practices, sometimes you'll have the mass number, or sometimes you'll have the number of neutrons, so you can get the mass number. But sometimes you don't, so you'll have to look at your periodic table. So like if we're looking at element number 11, which is sodium, 22.989, so I would round that to 23 and use that as my mass number. So you kind of only do that as like a last resort. All right. So we're going to look at some isotopes of hydrogen. They're very common. They're so common that they've been given their own names. So you can see that they all have the same number of protons, because we said that that's not what is changing. They're also neutral, so they all have to have the same number of electrons. So what is changing when you talk about the three isotopes is their number of neutrons. And because the number of neutrons are changing, then that means their mass number would change. So they would be different isotopes. So if I wrote the nuclear notation for these, for proterium, it would be H. It still would be a 1 because that's not the number that changed. And then at my mass number, I would have protons plus neutrons. So that one would also be a 1. Deuterium, once again, it's not the atomic number that's changed. So that's still 1. But now my mass number is 1 plus 1. So that becomes 2. And then tritium, H, 1. And now 1 plus 2 would give me 3. So those are the 3 different isotopes of hydrogen. The mass number is changing because the neutrons are changing, not because the protons or the electrons are changing. All right, go too far. So if you like a little mnemonic, 8-man may help you remember that. Atomic equals protons and electrons, and mass equals atomic number, mass minus atomic number, equals your neutrons. If you need a little mnemonic. So let's look at a couple of these and we'll look at some of the practices. So we'll start with uranium. Uranium 235. So that's the isotope. I want to figure out how many protons, how many neutrons, and how many electrons I have it on it. So to get my protons, I need the atomic number. So I got to find uranium on the periodic table, and its symbol is U. It's down in one of those pulled out areas because it's radioactive. So what is its atomic number? 92, right? So that means it has 92 protons. And because it's neutral, it also has 92 electrons. All right, so how many neutrons would it have? What do we do to find our neutrons? Perfect. Mass, this is my mass number minus my atomic number. 100 and what do I have? What did I do? Why do I have 143? Okay. Anybody else get, what did we get? 143 or 146? Anybody? 235. Right here. Right there. If you have the mass number, be sure and use that and don't use your estimate. That's a good way to find that out. So you want to use, so like even if I would have been given my number of neutrons, I would have wanted to add my neutrons and protons together and use that as the mass number. I only use that estimation as the last resort. Okay. All right. So why don't y'all try carbon 14. So it's the next one. Carbon's at the top of the periodic table. It's one we use a whole lot. So see if you can come up with how many protons, neutrons, and electrons you have. That's supposed to be a 14. And I know y'all did this in middle school. Did y'all have Michelle Stetter or she had already left by the time y'all were there? Who? All right, so how many protons do we have? 6, and neutrons, 8, and electrons, 6. All right. So that's part of your practice is on that. And then also it's on ions. So I know you have a blank sheet of paper because I copied them wrong and wasted paper. They're just copied on one side. So if you'll flip to your back piece of blank paper, you're going to have to add some stuff about ions. All right, because you have one whole practice sheet on just ions. And so obviously you see it on the quiz, and we use ions a lot during the year. So ions are elements that have gained or lost electrons. So no longer neutral. Because if they gain them or lose them, then my protons are not going to be equal to my electrons. So now they're no longer neutral. Metals, and if you remember, most of the periodic table are metals. And this is, if you go through the stair step, it may be marked on y'all's green a little bit, but on the one up here, the classroom one, it's marked real dark. So if you're at the stair step, if you come back this way, all of those are metals. So it makes up the majority of the periodic table. My non-metals are up in that other corner, and then we have a few metalloids that kind of stair step along the way. But all of my metals, so all of these things over here, they lose electrons. Try all of that again. Lose electrons. And if they lose something negative, that means they are going to become positive ions. And we call those cation ions. And then my nonmetals, except for my noble gases, because remember, noble gases are stable, so they're not going to lose or gain electrons. So my non-metals are going to gain electrons. So they become negative ions, which are called anions. So when you name an ion, there's a couple of different things you need to do, whether it's a positive or negative ion. And you'll see this is included in your practice too. I wrote it off to the side. So if it's a cation, which means it's a positive ion, I think of the T as cation as a plus sign. So if it's a cation, you're just going to use the regular name, and then you're going to add the word ion. So like Ca2 plus, that would just simply be calcium. I keep that the same. And then have to tack on ion to it. If it is an anion, then I'm going to change the ending to ide, IDE. Ion, the word ion is optional. Because once you see that ending change to ide, that tells you it's an ion. It's no longer neutral. So you don't have to put ion, but you can. So an example of that would be oxygen likes to form a -2. So instead of saying oxygen ion, I changed the ending to ide. So oxide would be the ion. And then you can add ion if you want to. You don't have to. And if you look at the back on your green sheet, we haven't started using those yet, but at the top, it shows you a lot of the endings are already changed for your negative ions. Instead of it being listed as oxygen, it's already listed as oxide or sulfide or phosphide. So that may help you remember that. All right, so we're going to look at some examples of this. So if we look at calcium 2+, 40, 20. So there would be my nuclear notation, but it's a 2+, so it's an ion. I still want to do the same thing. So my protons don't change. So that's still my atomic number. So calcium, it's the element number 20. So that hasn't changed. My neutrons have not changed. I still can do my mass number minus my atomic number. So 40 minus 20 gives me 20 neutrons. What has changed because it's an ion is my number of electrons. So I no longer have 20 electrons. How many electrons do I have now if my charge is a +2? 18 electrons, that's right. I had 20, I lost 2, and that's where I came from my 18 because the electrons are negative. So if I lose something negative, it has to become positive. And I would name this calcium ion. We'll do one -1, probably running out of time. Don't really know. Oh, perfect. We'll get through. Perfect. Don't be pushed. And we're going to do our same thing. And there's a whole page on your practice. You'll see that it's just ions too. So you'll have plenty of practice on it. All right, sulfur. So how many protons do I have for sulfur? Sulfur is S. 16, perfect. How many neutrons do I have? 16 also, because 32 minus 16 is still 16. But now how many electrons do I have? 18, that's right. It's -2, so I had my original 16 and I gained 2. That's where I got my 18 from. And instead of sulfur ion, because it's a -1, we name it sulfide. And you can put ion, you don't have to. And if you notice on the back of your green sheet on the periodic table, it's already changed. The -2 already has a name change for you on that. So it kind of helps you remember that a little bit. So we'll have a quiz over this on Thursday, no quiz tomorrow. You do have a video to watch, but this gives you a couple of days to do some practice on it. You may be completely comfortable with that first page because I know y'all probably did a lot of that in middle school. And then you have the whole sheet that's just ions if that's what you think you need to work on. All righty, I think. No, that you got your grade for the timeline by getting to use it on your quiz. All right. So please watch your video tonight. It'll help you with average atomic mass tomorrow. And then that'll be kind of be our last concept for this week.